Assalamualaikum and good evening to Encik Amri. Today we are going to present our project automotive ergonomics. Okay, next slide. Okay, our introduction. This is our organization chart. Siva Shankar as project manager. Then Muhammad Jazli bin Norizan as human factor engineering. Muhammad Ari Azfar bin Muhammad Hazi as risk engineer. Wan Muhammad Hafiz bin Wan Azir as failure analysis engineer, and myself Fidas bin Daud, cost engineer. Okay, our objective is to do comparison which vehicle is better for average Asian man or woman, to identify the muscular effect which is associated with driving posture, passenger posture, and open or closed trunk lead that may contribute to muscle fatigue by using ruler tool. And next, to identify the associated risks involved in this project using process failure modes and effect analysis, PFMEA. Okay, our car selection is PERODUA AXIA and PERODUA AXIA and PROTON SAGA FLX. Both of this car is in A segment, and the posture that we selected is driver posture, passenger posture, and posture during open and closed trunk. Okay, this is our project schedule. We have made it in Gantt chart. Okay, this project has been done in 5 weeks, and we have started it in 21st of December 2020. Okay, next. And this is the cost of this project. First is direct material. The total of direct material is RM524.25. Direct labor is RM30.46, and the applied overhead is RM890. So next slide. So the total job cost is sum up to all the three costs before, we got RM1,427.71. That is the for total job cost. Okay, method.
Okay, for method, I present as Muhammad Jazli bin Norizan as human factor engineer. Method that we choose is ruler method. A single place worksheet is used to evaluate required body posture, force, and repetition based on the evaluation score. Scores are entered for each body region in section A for the arm and wrist, and section B for the neck and trunk. After the data for each region is collected and scored, tables on the form are then used to compile the risk factor variable, generating a single score that represents the level of MSD risk. This is the three posture that we choose: driver posture, passenger posture, and lastly posture during open and closed trunk.
Alright, for risk management, I will present as a risk engineer. So the potential failure modes for this project: the seat dimension is not suitable for customer, seatbelt does not fit or the position is too high or too low, inadequate vibration isolation. For the cushion, customer sinks in the seat too much, seat grip not held tight enough during cornering, and seat is lack of style, head restraint contact, head in normal driving position, and natural frequency ranges overlap. For the trunk lid, the material not as per standard, the position to open the trunk is too high or too low, and it has small size head space, the edge dimension appearance, and lacking style, not enough grip to open trunk, and lastly, not good assembly of trunk and sub-assembly part.
Okay, now my name is Shiva Shankar from 3BMA as a manager. Today I want to talk about the driver and the passenger seats. The table is divided into 3 segments, which is effect of potential failure, potential cause, and action taken. And also divided by 3 segments is divider, passenger seat, and trunk and lead. The first segment is customer experience seating comfort. The potential cause is that the seat is too narrow or too wide and inappropriate decoration of available cross car width. The action taken is that the changes dimension of seat, procedure, appropriate allocation available cross car width. The second one is that the customer dissatisfied with the seatbelt function. The seatbelt is too tight or loose, contact the body in an uncomfortable location, and the action taken is that create a objective test. The third one is that cause abdominal points. Abdominal points which calculation cause forms is too thin, and the action taken is that increase the thickness of the form. The fourth potential failure is that the seat is too soft will bring negative impact on long-term comfort position. This cause that cushion is too soft. The action taken is that increase the hardness of the form. And another effect is the customers complain about the insufficient lateral support. The potential cause is the seat belt insert is a flat and convex as opposed to concave. This action that we produce is that to produce a concave feedback. For the trunk lead, we know that there is no productions with potential failure. The potential cause that cause the trunk lead is that supply failures and poor inspections. And the action taken, research the supplier for an update and ensure supplier certificates. The second one is that customer complains about the inconvenience to open the trunk. The potential cause is that misschedule the dimension for the positions. And the action taken is makes an exercise for the and another process is that failure at the users and have the bad posture. The potential cause is that not good dimension and the trunk and provide a good design, provide good dimension and lead. Another failure is that causes an assembly problem, function problem. The potential cause is that dimension is not well calculated. The action taken is that adjust each dimension of trunk lead. The second last failure is that customer will not buy the cause is that trunk lead shape, dimension, material selection missed the mark. Develop a complete trunk lead styling. Customer will have a hard time to open the trunk caused by the lack of design research. And the time taken is that provide enough trunk lead grip. And the last one is that function problem, not production. The potential cause is the personal error, and the action taken is the automate and manual assembly. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Afif bin Wadazir, is the failure analysis engineer. So I will proceed to the result of the experiment. So here the table of the result, it depends on the posture that even that we choose for this experiment. Okay, it was discovered when studying this post that there are so many uncomfortable posture that cause employees physical stress. Such uncomfortable posture have been replicated several times. So they had to be analyzed and eliminated or substitute by a replacement. In order to simplify tracking, we summarize the result of the ruler study in this table and include the below table to list the degree of MSD risk below. So we can see that the step score 7, 4, 4, 5, 6 and 3 depends on the posture, ergonomic posture, and the score depends on the level of MSD risk. As above, the final score for the ruler analysis was given to obtain the level of score of the posture we studied, how to threaten the posture, and what action we need to take to solve this problem. This score will be added to table below. We can establish association between different vehicles with the same posture for the process of defining and solving problem. Next. So the conclusion for this experiment, in everyday operation, ergonomic standards are not commonly practiced. The study shows that vehicle behaviors result in high risk and possible consumer accidents. Therefore, to prevent MSDs, further investigation is required. Using roller analysis, uncomfortable posture are analyzed. It was used by the consumer in highly stressful situations such as traffic stop. In the current workstation, modifications are needed to decrease the roller ranking, such as providing a more relaxed posture. Finally, it is conclude that ergonomic evaluation is important in order to identify the suitability of the car user's posture. So that's all from us. Thank you.